table for toggle flip-flop. Now we'll see conversion of flip-flops. Conversion of flip-flops. If one flip-flop is given, then it can be converted into a required flip-flop by doing the following procedure. First, we should know required flip-flops characteristics table. Suppose we want to convert uh, SR flip-flop into uh, T flip-flop, then we should know the characteristics table for T flip-flop. If we know the characteristics table for T flip-flop, then we can proceed further. Next, available flip-flops excitation table. If both these required things are known to us, a flip-flop can be converted into other flip-flop. We'll take one example. Convert JK flip-flop to D flip-flop. Already we have converted. We know how to construct a D flip-flop using JK flip-flop. Now we will follow the procedure of flip-flop conversion. First we will write the required flip-flops characteristics table. D flip-flop is required flip-flop. Its characteristics table DQN and output Qn plus 1 depend on these two inputs 0 0 0 1 1 0 1 1. We know that for D flip-flop Qn plus 1 equal to D. So Qn plus 1 will be simply equal to D. This is the characteristic equation for characteristics table for D flip-flop. Now we will draw the excitation table for JK flip-flop. This will be written in continuous. JK flip-flop is the required flip-flop, so we will write here J and K. And now we will write the excitation table for JK flip-flop. Excitation table for JK flip-flop, we know that if this is Qn, this is Qn plus 1, 0, 0, 0, 1, 1, 1, 1, 0, 1, 1. These are the four combinations. And for JK flip-flop, the excitation table is for 0, 0. Output, if previous output is 0, next output is 0. J is 0, K is either 0 or 1, written as cross. For this combination it is 1 cross, for this combination it is cross 1, for this combination it is cross 0. This is the excitation table for JK flip-flop. This will be applied here. If previous output is 0, next output is 0, J and K should be 0 cross. If previous output is 1, next output is 0, J and K input should be equal to 0 1. Sorry, cross 1. If previous output is 0, next output is 1, J and K input should be 1 cross. And for 1 1, it is cross 0. So this is the excitation table for available JK flip-flop. Now we'll solve for J and K. Zero cross 1 cross. First we will solve for J. Only one pair. So J will be written as D. Now we'll solve K map for K. cross 1 cross 0, only one pair, only one pair, and K will be equal to D bar. Now we will implement D flip flop from JK flip flop. We have given this JK flip flop, J and K are inputs, Q bar are output. This is the JK flip flop and it will be converted into D flip flop by connecting directly J directly to D. So this will be taken as D. One input is taken as D. J will be connected directly to D while K will be inverted form of D. So D will be inverted and will be connected to K. So this flip flop will now be called as a D flip flop, delay flip flop. This JK flip flop is converted into D flip flop. Now we'll see the race around condition, which was earlier discussed. Uh, it is the disadvantage of JK flip flop. We know that in a JK flip flop, these are the JK inputs, Q bar. If J input is 1, K input is 1. In this case, if these two inputs are applied, then in this case, the output Qn plus 1 means next output will be equal to Qn bar, means complement of previous output. If suppose previous output was 0, then this time output will become 1. But this behavior of JK flip flop may create a problem. See how this clock signal is applied to the flip flop to in order to trigger it. Triggering means the instant where flip flop will be triggered, it will look at the inputs and accordingly the output will be changed. If clock is not applied means flip flop is not triggered. If flip flop is not triggered, even if we have applied any input, output will remain in previous state. Output will not change according to input. For changing the output, it should be triggered by applying the suitable clock to JK flip flop or any other flip flop. So this clock or triggering of a flip flop are of two types. One is edge triggering, other is level triggering. If flip flop is edge triggered, then there may be two types of triggering. One is positive edge triggering, another one is negative edge triggering. And in case of level triggering, there are two types of level triggering: positive level triggering and negative level triggering. Now, how flip flop is triggered? We'll see. The triggering signal is clock signal, which is a square wave. This kind of wave, square wave. This square wave will be applied at the clock input of flip flop. If flip flop is made to trigger for positive edge, suppose this is the clock pulse. If a clock changes from 0 to 1, then only there will be positive edge. If a flip flop is positive edge triggered, then at this positive edge, flip flop will be triggered and it will look at the input and change its output accordingly. So flip flop will initiate its operation on the positive edge of the clock pulse. If flip-flop is designed for negative edge triggering, then for the mm, change from 1 to 0 in the clock signal, flip-flop will initiate its operation and will see the input, accordingly will change the output. If flip-flop is designed for positive level triggering, then it will be triggered only if there is positive edge at the clock input. If it is designed for negative level triggering, then it will be triggered only for negative level of the clock signal. If it is designed for positive edge triggering, if there is any positive level, negative edge, flip-flop will not be triggered in this particular part of this clock pulse. Only if there is positive edge, flip-flop will be triggered. Now we will see what is rest round condition. Now see, we have this JK flip-flop, and at this clock input we have applied a clock signal like this. This is the clock signal, and this is the time period of the clock pulse, which is called as T clock, and this is on period of this clock signal. On period. If this flip flop is designed for positive level triggering, then this flip flop will initiate its operation if there is positive level of the clock signal. And if this flip flop is triggered, it will see the input and accordingly the output will be changed. So there will be some time delay between this between the time when input is applied or flip flop is triggered and the time at which the output was changed, and this time difference is called TPD, time propagation delay of flip flop. Means after seeing the input or after the flip flop is triggered, it will change output after some time, and this time delay will be called as propagation delay of the flip flop. Now this is the output of flip flop will be noted. Suppose initially we have output equal to logic 0, and this level will be called as logic 1. Now at this point the clock has changed from 0 to 1. There is positive edge, but flip flop is designed for positive level triggering, so there will be no triggering for positive edge. Now at this point there is positive level of the clock and flip flop will be triggered. For this positive level, flip flop will be triggered. If flip flop is triggered, it will change the output after some time. After some time, this time is called TPD delay. This time is called TPD delay. Now, once output has changed from 0 to 1, the flip flop will again look for the clock whether it is positive level or not. If there is positive level At this instant, again the flip-flop will be triggered. It will see that the there is positive level. It will again be triggered, and exact after TPD delay, the output will again change from 1 to 0. Now again, when output in operation has completed, at this instant again this flip-flop will see whether the clock has positive level or not. Again there is positive level. At this point flip-flop will again be triggered, and after exact TPD time the output will change. In this way the flip-flop will be triggered multiple times in a single clock pulse, and output will in this way will change. Here the output now will become logic 1. Now see, in this case, in a single clock pulse, flip-flop is triggered multiple times. If flip-flop is triggered multiple times, its output for every triggering will be its complement of the previous output. Suppose previous first output was 0, it will be changed to 1. Again after triggering it will be changed to 0, 1, 0, 1, 0. In this way the output will be changed multiple times in a single clock pulse, even if input are at constant level 1, 1. So output is changing multiple times. At the end of clock pulse, we don't know what will be the output. It may be 0 or it may be 1. So output is uncertain, and this condition is called race around condition. So this race around condition can be avoided. One solution is that the flip-flop is taking a time of TPD for changing its output after triggering. So if we make this TPD time greater than T on, means T on time, T on of a clock is made less than TPD delay of flip-flop, then this race around condition can be avoided. But one condition should be satisfied, that it should be less than one clock pulse of the flip-flop. So this is the one condition where we can avoid race around condition, that TPD or T on should be less than TPD, should be less than T clock. So by satisfying this condition, we can avoid the race around condition in JK flip-flop. Another one solution for this is that avoiding the level triggering of the flip-flop. Use of age triggered flip-flop will help to avoid this race around condition. Use of age triggered flip-flop. And third solution is use of master slave JK flip-flop. If we use master slave JK flip-flop, race around condition will be avoided. Now we'll see what is master slave JK flip-flop. A master slave JK flip-flop is basically two SR flip-flops back to back connected or cascaded, and the feedback is taken from the second flip-flop to the first flip-flop input. Earlier we have constructed the JK flip-flop from SR flip-flop. Same will be the construction for master slave JK flip-flop. This is one SR flip flop. This is another SR flip flop, and master slave JK flip flop will be uh, constructed by this, taking this feedback from the second flip flop to the first flip flop. This is how the feedback is taken from the output, and again the clock signal will be directly applied to the master flip flop, and its inverted form will be applied to the second flip flop. This first flip flop is called master flip flop, and second one is called slave flip flop. This structure, this circuit is called master slave JK flip flop. In this master slave JK flip flop, first flip flop is called master flip flop, and it is applied to the clock. It has applied clock directly, while inverted clock is applied to the slave flip flop. And if J and K inputs are logic 1, in this case, the if we have applied a clock, this clock will trigger only master flip flop because we have applied inverted clock to second flip flop. That is slave flip flop, and the final output is taken from the output of slave flip flop. So if we have applied J and K input as 1 1, in this case, if flip flop is triggered multiple times in single clock pulse, then its output will either be 0 1 or 1 0. Means 1 1 output at this master flip flop is not possible. If 1 1 output is not possible here, slave flip flop, the input at this slave flip flop cannot be 1 1. It will be either 0 1 or it will be 1 0. So the race around condition will be avoided. Now here the points to be remembered are: master is applied with clock directly, slave is applied with inverted clock, final output is the output of slave flip flop, not the master flip flop. Slave flip flop. So output will be obtained when slave flip flop is triggered. So if a slave flip flop will be triggered, we will get the output.